Hi there, and thanks for watching. This is Lab 3, DC and RC circuits. The purpose of this lab is 1. To predict the behavior of circuits containing resistors in series and parallel. 2. To use multimeters to measure the actual values of conventional current and potential differences in the circuits. And 3. To examine the behavior of ohmic resistors and capacitors. A couple core concepts that are important to this lab. First, we're going to be using the circuit loop rule, which states that the potential difference around a loop in a circuit is always equal to 0. Next, we're going to be using the concept of resistance, particularly resistance of resistors in series. Some more concepts that will be useful, particularly in the second part of the lab. We're going to be using the concept of capacitance, RC circuits which contain a resistor and a capacitor, and the equation that dictates the capacitor charge or discharge rate with respect to time in an RC circuit. This is the experimental model. In this experiment, we have two parts, a DC circuit and an RC circuit, so we have one model for each. For the DC circuit, there are two batteries and two resistors arranged in series as shown in the diagram. The net resistance is additive, and the current is the voltage divided by the resistance. For the RC circuit, we're modeling the discharge part of the experiment. Here we have one capacitor and one resistor, as shown in the diagram. As the capacitor is discharging, the voltage across the capacitor with respect to time is inversely exponential and is given by the equation shown. The system in this case is whichever component of the circuit is being measured, and the surrounding is the rest of the circuit. So here's a brief preview of the results. On the left, we see a graph of the voltage across various components in the DC circuit. And on the right, we see the log of the voltage across the capacitor in the DC circuit with respect to time as the capacitor is discharging. So for the DC circuit, we have two 1.5 volt batteries, two ammeters, one 47 ohm resistor, and one 100 ohm resistor. The procedure for this experiment is to first measure the current across the ammeters, and then to connect the voltmeter across various components of the circuit and record the voltage. So here are the results for this first experiment. Again, we measured the current and the voltage across various components of the circuit. Note that the voltage goes up 3 volts across the batteries, down 9.96 volts across the first resistor, and down 2.04 volts across the second resistor. So here are the theoretical and experimental calculations for current and resistance. Note that there are slight differences, more on that later. So here's the setup for the RC circuit. Note that we have a switch on the bottom for charging the capacitor and a switch on the top for discharging the capacitor. We also have a 30 ohm bulb that acts as a resistor and a 9 volt battery for charging the capacitor. The procedure here is to measure the voltage across the capacitor at various time intervals in order to understand the discharge rate. So here are the results of the RC circuit experiment. The main thing to note here is that the log of the voltage across the capacitor with respect to time as the capacitor is discharging is linear and is downwardly sloped as predicted. This is a comparison of experimental versus predicted results. In both the DC circuit experiment and the RC circuit experiment, there were very slight deviations, but the results were more or less consistent with what was predicted. There was no code involved in this lab, so there's nothing to show here. Some potential sources of error. First, the circuit software had limited precision, and second, the data collection for the DC circuit was done manually, so the time intervals were slightly inaccurate. So what if we had used an ammeter in real life? In that case, we would have seen more fluctuations in the readings, which would lead to slight inaccuracies. So what if the RC circuit had no resistor? In theory, this would cause the capacitor to charge instantly, but in real life, this would never happen because there's always some resistance. The wires have some resistance, the battery has resistance, and the capacitor has some resistance. So a couple key takeaways here. First, resistors in series are additive. And second, in a DC circuit, the log of the capacitor voltage is linear with respect to time as the capacitor is discharging. Again, this was Lab 3, DC and RC circuits. Thanks for watching.